Good afternoon, everybody, and welcome to Zahn Academy. Today is the first part of a three-part series in 3Shape design. Matt Viens is here with us, and he is our high-tech trainer, supervisor for Zahn Dental, and he will be presenting this live design course on single crowns and 3-unit bridges. Matt will take questions at the end of the presentation, so please type them in at the bottom of your screen. And he would like this to be very interactive. So we do have a couple of poll questions that we will be launching during the presentation. So please, if you wouldn't mind answering those questions for us. Thank you so much. And here's Matt.
Thank you very much, Fran. If you want to go ahead and just start that first poll, we can start the first poll. But I just want to introduce myself. My name is Matt Viens. I am the supervisor of the High Tech Training team here at Zahn Dental. My experience was that I started back with CAP back in 2010, and we joined with Zahn in 2016, where I kind of had a strong focus and experience with the dental lab industry, primarily focusing on the training and support of 3D dental CAM or CAD equipment. I do have a little bit of dental lab experience from our partner lab during my CAP time, where we had a lab above us that kind of allowed me to view the analog processes and whatnot that a dental lab would typically go through. And that kind of aided me through my digital development and helped me to understand what the process was digitally and how that translated from an analog fashion to kind of better understand what we were looking for and how to achieve the results that we're looking for. I do have a strong passion for supporting our customers and training our customers on the equipment. It's something that I've always had, and I've really developed it throughout my years and my tenure with CAP and Zahn. And I do have a few hobbies, just including hiking, rugby, fishing, camping, and brewing. So with that said, now that you know a little bit about me, we're going to go on and talk about the two aspects of design that we're looking to go over today, which is the first one is going to be single crown design, which is your basic crown design that everybody starts off with. And here we're going to talk about the design workflow and the individual steps that we see within that workflow and how they coordinate to create a uniform design all throughout the process here. And then after that, we're going to take a look at the 3-unit bridge design. And we're going to talk about the differences between that and an individual crown design and how we can utilize more steps or different steps throughout that process to finalize our bridge and get a unique result. So with that said, let's go ahead and dive into, go back here, dive into 3Shape. And we'll go ahead and open up our first case, which is going to be the single posterior design. So on the single posterior design, we're going to first open up the case that has already been scanned for us. So we already have our case annotated and scanned in. So everything is just going through the design process. When we have scanned a case, the first thing that we're going to do is we're going to prepare the order, which is basically taking the scans and aligning it into the development that we have here as far as an arch goes. So I'm just going to go ahead and kind of idealize this arch just over the location. And this will help us when we go through the excursion and protrusion movements we have with our virtual articulator that we're going to talk about a little bit later. So the prepare step allows us to go ahead and adjust this occlusal alignment, which is basically putting the teeth inside this preform here to go ahead and idealize it within the virtual setup. And then we have two other options which allow us to do editing along the scans that we already have incorporated into our design. So the first one is sculpting the upper jaw. At this point, we can go ahead and take a very close look at our case and see if there are any imperfections that we would like to tackle. So for instance, if there was like a bubble on the model, we can go ahead and fill that in or kind of idealize it. Or if we had any sort of ridges or inverted triangles that might be an issue with our design developing into these interproximal areas, we can adjust that now as well. The careful thing that we want to do is we don't either want to overdevelop or cut into existing model textures, because that will take away from the individual design in those relative areas. So we want to kind of keep these areas untouched as much as possible and just develop them where we need to. So if I'm looking at this case, I really wouldn't want to develop anything over here since nothing's going to be happening over here. But we're just looking at the areas that are really crucial to our design and just seeing if there's anything interrupting or impeding on our design that might be an issue. So we can go ahead and address that as needed if we need to, or seeing that this one is okay, we can move on to the next case, which is sculpting the upper jaw. Now, since this one we're looking at, we're looking at tooth number 3 over here, we're going to go ahead and look at the opposite side because that's going to be the opposing. And I can actually turn on my other jaw to see where we're hitting over here. And I'm just going to look at that opposing area to see if there's any interruptions in that model as well. So again, we're utilizing our sliders that we have in our upper viewport over here and just seeing if there's anything that needs correction at this time. And that's simply what the prepare step does. It allows us to use these individual tools, which allow us to either sculpt with the wax knife tools, like adding, subtracting, or smoothing on the model. And here you can see we can add a ridge. We can carve into the model. Or we can even smooth out, which is kind of finding like a happy medium between the two areas to kind of smooth out any sort of transitions that we have. Another option that we have during the stage is the remove artifacts tool. And this one just allows us to go ahead and paint an area that might be of concern. So if you see any sort of funky triangles or any sort of areas within the model that don't look true to the actual model itself, we can highlight that and hit play, and it tries to remove that artifact. With this one, since I'm enveloping on an outside area, it won't allow me to do it. It only allows us to kind of highlight areas that are internal or fully engulfed in triangles on left and right sides. And it basically just takes that area and it smooths it out. It finds the median between those areas and kind of smooths it out and prevents any sort of inverted triangles or anything like that that would normally cause issues with our scans to be flattened out and reverse the normal so that they're correct. If anybody doesn't know what a normal is, it's basically the difference between looking at the outside of the model versus the inside of the model. And it's basically just the software dictating which side's inside versus which side's outside. So again, I can use this option to go ahead and trim up or further prepare our models. And the last one that we have is the option to extract teeth. So if I didn't have this tooth or we knew that this tooth was going to be extracted, we can go ahead and click on the top. And it allows us to go ahead and edit the model to assume that this one's going to be an extracted tooth during the design portion. And we can go ahead and hit apply. And that way we can utilize this function during our design, knowing that this tooth would be extracted prior to the restoration going into the mouth. But since we're not worried about that today, we're going to go ahead and undo this. This is just knowledge for future instances. If you ever have to make any sort of preparations on either arch, you have those options available to you, and you have the availability to do whatever you would like to do within the models. So moving on to just the overall user interface of this case, we're going to be seeing the navigation panel, which is going to be this actually in the middle here is going to be our navigation panel. And this basically highlights the big steps that we're going to be going through. The first one being the prepare step. The second one being our segmentation or annotation step. The third one is going to be our direction step. This is where we set our insertion path for the unit. Then we go into our interfaces where it allows us to go ahead and draw the margin and identify where the cement gap is going to be on the unit. And then finally, we go into the anatomy design, which is the bulk of the designing stage. After that, we have a save or finalize stage. Now, this case has already been set up to idealize the single crown design. But if we wanted to, we can go ahead and take another look back at the order by clicking on this option. It does take a long time to go and open that, unfortunately, so I'm not going to do that today. But if we ever had to make any changes, whether it be to the material itself or the crown that we selected, say I selected the incorrect crown, we can go ahead and make those changes without exiting the dental designer software and go straight into the design after we've made our adjustments to the order form. So after the navigation panel, we have our step stage. An individual step is going to be listed out here. And then underneath that is going to be your sub steps. So each step is going to have its major portion here and then the minor portions underneath it. If If you click on this, it does allow you to kind of minimize or hide those individual areas. And then each sub-step will have a list of directions or a manual of arms that we're going to be using to go through that sub-step and complete all the necessary required tasks within that. So I should have probably said that prior to this, but at least we do have that knowledge going forward. So let's go ahead and move on from the prepare step. We're going to now look into our segmentation step. So with the segmentation step, during the scanning process, it already has you do this. It basically separates the die separate from the full model scan. So we can see here that the die is of much higher quality or finer quality because we did an individual scan specifically on this piece of the model versus the whole model, which encapsulates the very high detail where it's necessary, but it's not as detailed as we need it to be on the crown. So it will allow us to go ahead and capture those nice available areas that we need for solidifying our contacts, but it doesn't have the quality that we need necessarily around this margin, which is going to be that high crucial area of our design point. So at this point, we're looking at the annotations, and the annotations are basically going to say what tooth we're designing. Now, I do have this annotation set up as the FDI notation, unfortunately. So it's at crown listed as 1/6, but it's actually, if we looked at the universal setup, it would be the third crown, the third molar. So we're going to go ahead and move on here. But if we wanted to, we can go ahead and take a look at our annotations. And the annotations is just this dot that we see on here. This dot has been placed during the scanning process, and it helps to identify the difference between the die versus the rest of the model. At this point, we can ignore the scanning annotations and we can choose whatever we want to be the die. So if I wanted it, I could be over here. But you notice that the model turns a different color from this segmented area. That's because it's choosing this to be the area that we're going to be placing our crown on versus this separate scan that is segmented from this lower quality scan here. And so you can see the difference between the two different colors. That's how we can identify whether or not we've selected the correct annotation on the unit versus the rest of the model that we're working with. So this one wasn't correct, so I can either click and drag it over to where it needs to be correct. And now you can see that it highlights the die correctly as we see here. Or I can clear all scanning annotations and add my own annotation. Now we do want the annotation or this little dot to be on the buckle around the midline of our unit, because that's going to help differentiate the process going forward when it goes to select or input our idealized crown design. It uses that as a reference point to determine which side is going to be the buckle. So I always put this on the buckle margin. Some people have put it on the buckle in the midpoint of the crown. I always like to put it right on the margin. That's just typically going to help us gather more information relative to the margin going forward and be a little bit easier for when we draw those margin lines. Next, we're going to move on to the direction stage. And the direction stage has basically one aspect here, which allows us to see the path of insertion for this unit. And if you can see on the path of insertion that we do have these red highlighted areas, these are going to be your undercuts as relative to this insertion path. So as we rotate around, we can kind of see those highlighted areas take place, but we can also see the relative direction of the insertion path as we see here. Now, we can either determine the insertion path by using points, by using a reset method, and we can use our keyboard or our mouse to edit the points around the margin line, which determine the best path of insertion based upon the curvature of that margin line. It does not take into consideration the axial walls or the neighboring teeth as relevant resources, but it just uses it based upon these points. And I'm just using the left or right mouse buttons, not the mouse button, sorry, the left or right arrow keys on the keyboard. And I can't really move this dot with my mouse, left or right. It does not use the mouse at this point. So instead, I'm just using the keyboard, and I can use the arrow keys up or down to move this dot relative to that red line that we see on the screen. So I'm not able to move it left or right. Rather, it selects a different dot to the left or right, and I can move it just relative to that red line. So I'm going to go ahead and put this right on those right on that marginal ridge that we see here. And I'm just going to grab the height of contour on that ridge just to make sure that green dot is encompassing that area, and move along and just kind of survey those individual dots and see that they're sitting on the relatively right points. Another option that we have is we can go ahead and place our own dots. And once we place that dot, which we can kind of see the height of contour with this highlighted line that we see here, we can go ahead and it automatically rotates the tooth around to allow us to select multiple dots. Now, this is not necessarily going to be something that we need to do. I'm just showing you as a point of fact because we do have an option to go ahead and use this to facilitate our insertion direction. All right. So I'm just going to go ahead and hit reset. But this basically allows us to go ahead and see that idealized path of insertion based upon where those green dots are sitting. If the green dot, for whatever reason, was sitting inside here, then you would want to change that to kind of help you with an idealized path of insertion. But if you didn't want to tackle those green dots, which a lot of people don't want to do, we do have another sub-step underneath here, which allows us to go ahead and change that insertion path based upon these arrows. And these arrows move in a specific direction relative to your view. So if I look at the bottom arrow, right now it's going to move a little bit more buccally, but it's going to rotate along a little arc. So I just brought the insertion path locally across the buccal. But now, since I've changed my view, if I go ahead and I select that bottom arrow, now it's going to bring it more distally. Okay, so these arrows only work relative to your current view session and are really dictating the location based upon your current view. So if I wanted this to be more centralized along the top, I could use these arrows just to kind of show exactly where we're going by looking at where the arrow is presenting in our current view. One thing I like to do at this stage is I like to see the reference between my axial walls and my neighborhood interproximals. And I take a look and make sure that I'm not creating any undue undercuts relative to my axial walls or my neighboring contacts, because I don't want something to be overly undercut in this area where we would only have a pressure point contact on the marginal ridge or so. So I want this to be really identifying the true path of insertion that we're looking at all aspects with the axial walls of our preps as well as our neighborhood scan. Okay, next we can go ahead and take a look at the undercuts, and you can measure the undercuts if you would like, which allows us to go ahead and see the depth of the undercuts. And we can see anything in yellow is going to be less than 10 microns, so we're okay with that. Typically, what we don't like to see is we don't like to see any of the undercut areas encroaching or passing through the margin line, because that will create an area in which the unit is not going to be able to seat down or fully close the margin in that area because there is impeding aspects of the preparation or the neighboring teeth causing it to be unable to adapt to that margin area. So next we're going to go into the interfaces step. And this one's a little bit more crucial because we do have two sub-steps underneath here. We have the margin line, and then we have the die interface. The margin line is just as we see here, is going to be the individual margin line that we see, or that is going to be our finishing line of the unit and to the preparation. So at this point, we can go ahead and click and drag our line where we want it to be. If we want to make subtle changes, we can go ahead and just do a single click, and it adapts the line as needed. Wherever I hover my cursor, you can see actually down here a little bit more, you'll see there's a little cross section that allows us to see the true height of contour in that area. So here I can see that my little blue dot that I see down here is actually below the height of contour relative to that edge. So I'm going to go ahead and drag this up to be located on that height of contour. All right, and I can kind of follow the green line to ensure that my blue dot is going to stay along that height of contour during this process. Okay, so I'm going to go ahead and highlight this area a little bit further. Now, we do have options to get rid of that little undercut or that little cross-section screen if we don't like it. We can right-click on the green line, and we can remove the show local cross-section option. This allows us to go ahead and just kind of take a look at the screen as is, and we can kind of see exactly where we want that margin to be and make some edits. Now, if we have to do a really fine tuning of the margin, we can right click on the margin and undo or unselect. Sorry, let me see if I can do it. Unselect the fast edit spline. So this isn't a spline where we go ahead and click and drag a line where we want it to be. That's called a spline. But if we uncheck that fast edit spline, it changes it into dots, and we have a little bit more freedom to go ahead and make finer adjustments to that margin line, but without making large adjustments to further areas. Now we can also add more dots if we wanted to and get really fine tuned in these areas. Or we can take away dots as well. If we have too many dots, we can go ahead and say remove this point, and then it kind of straightens it up to be a difference between there. Now, when we look at this, we don't want to be too overly complicated with this. It's okay to see the lines somewhat go through the model right here. That's going to be typically not an issue. So we're just going to go ahead and make the changes necessary that we see to adapt it to the right areas. Just make small changes, get this on the height of contour, and then we're going to go ahead and move forward. So looking at my margin, just going all around again. Maybe I want this to come up and over here, like that. Make another change, have it dip back down, and then come back over here. All right, we're going to make those adjustments, move on to our next stage. And now we're talking about the die interface. So the die interface is going to be the cement gap that we see between the unit and the die that we have here. If we take a look at the settings, the advanced settings, not these settings. If we take a look at the settings, we have the cement gap, the extra cement gap, the distance to margin line, and the smooth distance. I'm going to go ahead and just preview this to show you what the differences of those individual settings are and how they relate to the fit and the comfort of the unit and its fit directly to the die. So here we have this one set up for drill compensation, which we kind of see as a bubble around these sharp areas. And that's basically extra burr or drill depth in those areas to compensate for those sharp edges that we see around the unit. Now I'm going to go ahead and do a 2D cross section over here and really zoom in on this case to show you exactly what we're talking about. So as we look at the settings of the die interface, you can see that we have a further distance between the axial walls and the inside of our crown over here versus the fit on the actual the little ridge there that we have on our model down to where the margin line was created. So this is going to be called the actual cement gap. This piece here is going to be our cement gap, which we see is 0.02, 20 microns. Over here, which is going to be the distance between our axial wall and the inside of our prep, is going to be our extra cement gap. And this is going to be the distance between the unit and the axial walls for the fit purposes. And so we're going to have a nice snug fit down here, but it's going to be a little bit more passive along these areas to allow for more compensation or cement gap in those areas. The transition between the two thicknesses that we have here, which is the high thickness and the low thickness, is going to be our distance to margin line. Okay, so that's how much it makes that transition. I'm sorry, no, that's the smooth distance. It's that how much it's going to take that distance to smooth out from a large area down to a smaller or tighter gap. That's going to be your smooth distance. Now, where that distance takes place, or how long from the margin line it goes up the contour of the unit to increase that cement gap, or just to lay that lower portion, is going to be your distance to margin line. So starting from the margin line over here, it's going to travel 1 millimeter, okay, and apply this current setting of cement gap. Then from there, it's going to transition from the 0.2 or 0.02 to the 0.06, and that's going to take a distance of 0.2 millimeters. Should be somewhere around here. All right, and that's the transition distance, which is going to be the smooth distance. And then we can go ahead and assume our next piece, which is going to be the extra cement gap. So if we're looking for a little bit more passive fit, typically what we would do is we would increase the extra cement gap. If we're looking for a more intimate fit, if we want it to be a little bit tighter, we will lower this number, so it's going to be a little bit closer. Now, as you can see here, over these areas that are a little sharper, it's going to go ahead and apply a bubble, which is basically going to be in a milled out area or extra area that's going to be milled out with the burr due to the drill radius and the drill compensation offset. And that's relative to a 1 millimeter burr. Typically, we have these numbers set as our defaults because they are what work best. If you try to go with the 0.5 for a 1 millimeter burr, you tend to run a little bit too shallow with those areas, and it doesn't typically allow the 1 millimeter burr to get into there. So we give it a little bit more space to allow for a little bit of alleviation during that milling process and allow it to go ahead and encapsulate that area with the 1 millimeter burr. But that's only for milling purposes. So now that we've got that out of the way, we understand how important the margin line is and what the die interface does relative to the crown design. We can now move on to the next stage, which is the actual designing stage. So in the design or the anatomy design stage, we have the Smile Composer. Under the Smile Composer, we have the Smile Library, which allows us to go ahead and choose the library of the unit that we're going to be using. So if we didn't like the look of this occlusal attrition, we can go ahead and choose from different various libraries that we have available to us. And we can choose one with either more or less occlusal attrition. You can change it to being whatever you would like to be. Basically, select the crown you would like, and then it allows us to go ahead and place this into its location. So I'm going to go ahead and choose this library here. Typically, I don't like to design units with the cuspid carabelli, so I'm going to go ahead and just use this option here. And now we can go ahead and use our sculpting tools. So under the sculpting tools, we have a large various set of tools or different functions of the tools that we have available to us. Single tooth tools are the ones that we're going to be focusing on today, or in this session right here. And next, we're going to be talking about the multiple teeth tools during our bridge design. Under the single tooth tools, we have individual transformation, then we have our individual morphing, and then we have a wax knife, and then any attachments or a plane cut tool. And it's nice to think of this as working from our left over to our right and talking about large changes versus intermediate changes versus small changes. So with the global or with the individual transformation tool, this allows us to go ahead and grab the unit with individual handles that we see here, or dots. And those dots have different colors because they do different things. The red ones allow us to rotate. So I like to keep in mind R, red, rotate. And then the green allows us to go ahead and scale that individual size. So I can either drag out the buckle or I can suck it in a little bit. Or if the if the lingual is a little bit too far, I can go ahead and pull that in as well. If I wanted to go ahead and just drag the marginal ridge and not drag the whole side. So if a green drags the whole side, the yellow will actually just grab that marginal ridge. Now, one thing that the software does automatically is it sucks it down to the margins, but I don't like to do that. So I actually I like to remove it from the margin line, which is this option here, which is connect to margin line. Basically sucks our unit down to the margin line. I like to undo that first. So this is what it would look like if we sucked it down to the margin line. I like to undo that totally. So I have a kind of like a anamorphous plot that I can work with and set into place. And then once I have it set into place, then I connect it to the margin line. Because if I had connected it to the margin line initially, and then I make those changes, you tend to have a little bit of a twisting or rotation aspect happening to your crown. And it tends to twist down the bottom here. This is a little bit exaggerated, but it gives you an idea of what you're seeing. So I don't like to have to work with that sort of surface. Rather, I like to start with a freeform aspect and make it into place. And then from there, make the adjustments as needed. And then after I've made my big adjustments, then I can go ahead and connect it to the margin line. So again, as we talked about going from left to right, we're starting with our big changes. We're just making those generalistic changes that we have here. I'm going to go ahead and rotate this crown so that I have sort of the same style of ratio that we have here appearing from the top view as we do with our neighboring teeth. So I'm going to go ahead and rotate it into view, make the necessary adjustments. If I have to pull out any sort of area or suck in any other areas further, I can do that with multiple tools down the road, but I'm just going to make my big changes at this point. So just like we had in the prepare stage, we can also see our using our visual sliders over here in the upper right-hand corner, we have the option to turn on our opposing scan so we can see exactly where that tooth is going to sit within our opposing. And we have a good relation right now. So I'm going to go ahead and make just a few adjustments relative to this, and then turn that back off and just kind of focus on the design itself. So after I've placed my crown where I think it looks best, I might actually rotate this down a little bit here. Move this over. All right, once we've got it into place where we like it, we can then move on to the next stage, which is going to be, or the next step in our, or next tool, I should say, which is going to be the individual morphing tool, or the option that allows us to do intermediate changes. With the individual morphing tool, we go back to having more dots, and those dots control a different variety of things. We'll talk about those in a second. But we do have also this green circle and this sort of grid that appears in our view. Now, based upon where I'm holding my mouse, you can see that grid changes from a blue to a black grid. The black grid is going to be a 2D change, which we can see relative to that grid, versus if I have it on a angle here, you can see that the blue is now going to be a three-dimensional change. So I could be pushing and pulling versus moving left or right or up and down. So based upon how that grid is being viewed is going to indicate the change that we're looking to do. Also, we have an option if we go to the outside edge, you can see that the tooth becomes emboldened with this black line. That indicates that we're going to be morphing along a silhouette, which means we're changing not just this edge, but every edge beyond it. So it's actually changing this whole profile of the tooth. And so to grab that whole profile, we can grab that silhouette and we can make that change accordingly. Okay. So here, again, we're just using those intermediate changes to make the adjustments that we want to kind of finalize our design with. I'm changing my view constantly because I want to make sure that I'm true along all areas. And I'm going to go ahead and just kind of sculpt this down a little bit more. Maybe I want to go ahead and sculpt this up. And you can also see the green circle that we have around here. That's going to be our area of effect. So if I only want to affect a small area, I can change that by hovering over a dot and changing the size with the scroll wheel of our mouse. Or I can come over here and use the shift button and scroll wheel the mouse. So I can either use the shift or just hover over one of the dots with the scroll wheel. But the scroll wheel is changing the circle size. Now, if I also hover over a dot, you can see that there are dots of different or same colors or light colors. If I hit shift, it allows me to control both those dots or all the dots that are the same color at the same time. So I can do a symmetric design. So if I wanted to go ahead and just drag this up, I can go ahead and drag this up. Sorry. I can go ahead and drag this up to kind of make pronounced cusp ridges there. And then I can make slight changes over here to kind of mimic what we have. Okay. Now, if I wanted to get a little bit more accurate, I can do a smaller circle with the shift and the scroll wheel. And again, using that contoured edge allows me to redefine our design as we see. Now, if I went too far with my ridge, if I wanted to keep all those changes that I just made with the relative to the profile of the cusp ridge, I could hold the shift button and make my scroll wheel bigger to encompass the whole cusp shape and then just drag that down. So it allows me to keep the profile that we just made without losing any of our design. Okay. Again, with all those buttons or all those dots that are the same color, we can make changes to those options just by clicking and dragging and holding the shift button to select all the dots of the same color at the same time. So at this point, I'm just going to be dragging certain areas up. Now, another cool function of this tool is the option to use the control key, which moves from this grid pattern to an arrow. And the arrow just basically allows us to move in 2 dimensions, just straight up towards us or straight back. And no matter where the arrow is pointing, we're only going to be dragging our cursor, or the mouse is only going to be going up or down, straight up and down in a line. If I go left and right, it's not going to do anything. So I'll show you here in demonstration. If I hold the control key down and I get that black arrow, and if I go left or right, you see no changes are being applied. But if I go up, it adds, or if I go down, it subtracts. Okay, so just moving my cursor up and down changes the adding or subtracting of material relative to that black arrow that we see on the screen. So the black arrow is going to show us our direction, but the actual adding or subtracting of material is going to be relative to our cursor or mouse movement. Okay, so you can make adjustments there. We can go ahead and make our final changes. So at this point, I'm just looking at the overall shape of our crown and seeing what needs to be adjusted. Go ahead and thicken this up. I might bring this in because it's a little bit too much or impeding too much in this area. Just going to do some final changes. Maybe I bulk out this area down here a little bit more to make it a little bit more smoother. I can say maybe I didn't like that change that I did over there. I'm going to go ahead and bulk this out. And just try to get this into place where it looks like it's happy with what you've done. Okay, maybe I've done too much in this area. And go ahead and make those intermediate changes that we talked about earlier. Okay, so again, making this change out like this. Just looking to get it relatively into a good position that we like. Now, once I've made those changes, I can go ahead and move on to the next step, which would be the more detailed step of our units that we're looking to accomplish. So I would spend a little bit more time on this design, but I just wanted to showcase all the functions and features that we have available to us to kind of incorporate what we're looking to do. So next, what we have is, along with our visual sliders, we have our current model, which is our operative model, or the segmentation arch. We also have our active item, which is our current unit that we're working on. And then we have our clip plane, which allows us to kind of cut through the model and see exactly where our unit is looking. We can change that plane by hovering this around, and we're going to use that a little bit later. So basically cuts our model and allows us to kind of view in those interproximal areas. We also have a minimum thickness, which allows us to go ahead and see areas like this that are a little bit too thin for our material. So I'm going to go ahead and just kind of bulk this up real quickly. Use the control key and just drag up. Okay. And then we also have our die interface if we wanted to show that as well. And then finally, we have our options that we have for contacts. And these highlight areas where we're contacting either into our neighboring model, like on our interproximals over here, or contacting with the occlusion. And those are good to see so we can see relative areas that we're designing with and see if we're too high or too low in certain areas. Okay, so I could use my control key to go ahead and drag these areas up if I wanted to make more contact in these areas. I could do that. And that way we have nice functioning areas. All right, next we're going on from our intermediate changes back down to our small or finite changes. These are going to be highly detailed changes. So under the wax knife, which kind of looks like a spray can, it allows us to have an add, subtract, and smoothing option. The add is going to be controlled with a circle that we see presented on the unit itself. And that circle is changed just like with the wax knife tool, the morphing tool, with shift and the scroll wheel. Now, underneath that, you'll see something that kind of looks like a little mountain over here. That mountain is going to be intensity, or how much is going to be added or subtracted during each mouse click. So I can change the intensity by using the control key. So I can bring it down, and that way I'm only adding a very subtle amount to each of my click and drags, or I can do individual clicks. Okay. If I changed it up so it's very high, now I'm going to be adding a lot. Okay. And again, the area of influence is going to be more dictated by this circle size, and it's going to be more intense towards the center of the circle and gradiate out. So it's going to add more towards the center and gradiate out. Okay. Now we can go ahead and get crazy with this one. So you got to be careful with this. We got to go ahead and add a little bit where we need to. We can also do the same thing with the subtracting tool, which allows us to go ahead and do the inverse of what we just did. Or my favorite tool, which is a smoothing tool, which allows us to go ahead and kind of fix any errors that we see within our case. I kind of liken this tool to taking an open flame to a wax restoration, where it allows us to go ahead and kind of fill in any sort of divots or allow the wax to kind of mold into those divoted areas, and then kind of take down the peak areas as well. So we can use this option here. So I'm going to go ahead and just use this to kind of identify areas that may need a little subtle change and make those subtle changes. And then I can even use this to kind of take down those areas that we see that are a little bit too prominent, like over here. I can use the smooth tool to either bring it down gradually. Maybe my intensity is a little bit too high. So I'm going to bring that down. But you can see as I do that, I tend to wipe out my occlusal attrition. That's okay. I'm going to go ahead and show you how we can redesign that real quick again here real quick. Okay. So take this out of occlusion, or we can use one of the different settings that we'll see here in a second to kind of take it fully out of occlusion. So if we've made a lot of changes and we see that we want to add some more occlusal attrition, I can go ahead and take our cutting tool or our subtraction tool. I can get a small circle, and then I can go very intense with it, and I can go ahead and click and draw where I want those fissures or that occlusal anatomy to come in and really detail this area. Okay. So I can go ahead and draw out exactly what I expect this to look like and really create nice occlusal anatomy in this area. Okay. All right. Once I've gone in with a nice fine tool like you see here, what I like to do is I like to follow it up with a slightly larger tool just to kind of embolden those lines that we've already created. Because right now it looks kind of choppy and you can kind of see a very deep groove in here. I don't like to see a very deep groove. I like it to be kind of idealized. So I go ahead and I take just a slightly large tool thereafter to make it a little bit more smoother or translate a little bit better. So I'm going to go one step higher, just retrace. Whoop. Sorry, not as intense, I should say. So I'm going to bring it down to maybe half intense. I'm going to go ahead and just kind of retrace that. And allows us to go ahead and create some nice occlusal anatomy on here. Okay. So even though we made those changes in previous stages, we're now making up for those changes by adding that anatomy back in. That's to say, if you really wanted to do this, you don't technically have to do this if you didn't want to. If you don't want that nice anatomy, you can go ahead and leave it as is, and then just let it take precedence as you see fit. So after we've added our occlusal anatomy, we can go ahead and make subtle changes or finite changes to these instances that we see like we're hitting up here. And we can either do that with the subtracting tool, or we can do that with settings that we have under our smart tools, which are contacts and smoothing. And this allows us to go ahead and smooth out the full unit. Or sorry, first we're checking to make sure that there's minimum thickness, but I don't have anywhere that's too thin, so it won't let me do that right now. We can see our distance from our posing right here. We have the difference between desired distance versus precise distance. A precise distance will do an exact cut in that area, versus a desired distance will actually take it down gradually and give us more of a unique natural shape that we have. So I like to do the desired distance more so than the precise distance. And then we have an option that's going to be our desired distance to our neighbors, which is going to be our interproximal contacts. Typically, I like to go negative 0.05, and I hit the play button. And that will allow us to go ahead and tick away of all the material, but it actually leaves us into the contacts a little bit heavy by 50 microns. And this gives us a nice solidified area in that location. Okay. But another way that I like to do contacts, which presented itself around the 2018 version of 3Shape, is to use the subtraction tool. And then there's an option over here that's neighboring teeth undercut, which allows us to block out our undercuts on our neighboring teeth. Okay, which you can kind of see. I don't know if you guys can see this too well, but it takes the undercuts and it blocks them out based upon our path of insertion that we chose back here. And now we can go ahead and we can see where that unit is coming in. If I take this down and actually show just the under contacts, I can see where that unit is either deficient or proficient with our undercuts here. I'm actually going to go the same difference that we had before. So I'm going to be adding all the way. Oops, sorry, hit enter. I shouldn't have hit enter. That's my fault. Go back here. Okay, so I'm going to go and I'm going to be a negative amount on my neighboring teeth undercuts. And this is actually going to allow me to add in this area up to that specific amount. And the reason why I like to add in this area, because this is ensuring that this area is going to be into contact with our neighboring unit during that procession of the insertion direction. Okay, and so I want to have a nice broad contact as well as this is concerned for the interproximal goes. I want this to have a nice broad contact, but paying a note that we're not actually going to have this contact being directly this broad because it's just taking into consideration the path of insertion. So I'm just going to create it nice and broad right here, and then take away any areas that are overburdened in this area down again to that negative 0.05, which tends to be a nice number that we have for our interproximal contacts. So I'm going to go ahead and take away all that material. And what's left is, if I go ahead and I uncheck this and I remove all my models so I can see just my contact, we can now see our contact relative to the contact lines that we see here. And I'm going to go ahead and just kind of smooth these areas out, because if we take off those contact lines, you can kind of see a finite line around our unit. I don't like to see that line. I like to kind of have it disappear into my unit, but I know that it's going to be heavy. It's going to be a nice solid contact in that area. So I'm not going to change anything inside that area that I know is there. I'm rather just going to kind of develop the outside areas to kind of blend more so with my unit. Okay, again, over here, I'm going to go ahead and just kind of blend those areas in with my unit, being careful not to make more of my changes on the interior aspect of where that contact was. Okay. And then what happened when I accidentally hit enter is actually connected it already to the margin line. So I'm going to go ahead and just show you what that looked like. It just kind of created this extension of the margin line out here, which is that chipping edge that we have. So we're going to go back and just kind of smooth that edge with our crown. And this allows us to go ahead and smooth out our design. And now that we know we have a nice crown that is into occlusion as far as our design goes, and please don't judge me based upon my design. I haven't designed a crown in a while over here, but it may not look pretty, but we know it's going to be functioning within our occlusion, because we took it out of occlusion the necessary amount that we needed. And we also know that we have nice broad contacts with our interproximals because we set that predetermined amount in our wax knife tool on this option here. We set that to a negative amount, which allows us to encroach upon that, upon those interproximals, a positive amount into there. So it seats positively in there. Okay. So once we have all that determined and everything looks good and you're happy with this design, we can go ahead and move next, and we finalized our design. Now at this point, if we had any parts of the unit or any elements of our crown that were deficient as far as minimum thickness, it would give us some warnings, allow us to go ahead and manually or automatically adapt those areas as needed. Okay, so that is the single crown design. Let's go ahead now and take a look at the 3-unit bridge design. The 3-unit bridge design is going to be much like the individual crown design, only we have more elements to work with. So we're going to have similar stages up the top on our navigation panel, where we're going to be dealing with the prepare, the segmentation, the directions, and the margin lines, and the anatomy design. But we'll also have a last stage, which is going to be finalized. And this basically takes the 3 elements and it combines them into one solid monolithic element. So going from 3 individual crowns to one individual unit altogether. And then we have the stave stage. So I'm just going to go ahead and kind of force through this first few options or the first few steps, because we've already gone over those within the single crown stage, where we talk about the segmentation and we just confirm our annotations. Again, I apologize for having FDI on. I know that this isn't what we're typically normally used to, but we do know that this is 2.2, this is 2.3, and this is going to be 2.4. And we'll go ahead and take a look at the margin lines and the directions of the insertion path now. So here we're again surveying our case to make sure that this insertion path is correct, not only for our axial walls, but also for our neighboring teeth as well, to ensure that we're not putting in an insertion path that's not going to be feasible based upon the insertion of the unit into the patient's mouth. So I'm actually going to guide this a little bit more distally, just to kind of have it look a little bit better. And actually, I might drag it just a little bit more buccally as well. We can go a little bit more buccally. just kind of minimize the contacts on or the undercuts on our axial wall and our neighboring teeth. So that looks like a good insertion path for me. Looks true to the design that we're looking for. So I'm going to go ahead and look next. Now we're going to go ahead and draw our margin line. Again, we can turn off the local cross section, which I like to do. And I like to just kind of see exactly where the highlights are on the case as the software presents it. And then I'm going to use that as the height of contour for our margin line and make subtle adjustments for the margin. Okay, I don't want my margin sitting too low, but I also don't want it sitting too high. So I always want it to be on that nice sweet spot that we see kind of outlined with that shadow or that highlight that we see on the model there. Okay. Next, we're going to go into the other die's margin line. And here I have a little bit more of a wavy margin line. So I can make the subtle clicks, but sometimes that's not going to be adequate. I might have to go from a fast edit spline to the points and to do that nice final sculpting of that margin line. If I need to add a point, I can go ahead and right click on that green line and add a point like we showed earlier. And this allows us to go ahead and manipulate that margin line a little bit more accurately and place it however we want to. Okay. Sometimes it is faster, though, to go to the fast edit line. Just highlight the area that you're looking to change, especially if it's a large change like what I just did. It's easier to do the fast edit spline and then go back in with the points to do a more gradual or individual change. Or accurate change, I should say, not individual. Okay. So I'm going to say this is good enough for teaching purposes. I'm going to go ahead and push forward here. We all understand now how to design our margins. So let's go ahead and kind of focus more so on the design stages itself. So interfaces is going to be the same. If we wanted to go ahead and make this a little bit looser because it's a bridge, I want this to have a little bit more lenience. I'm going to go ahead and increase the extra cement gap. That's typically going to be the only one that you're going to be changing, specifically if you're going to be using materials that have these predetermined settings. The only one that you really want to mess around with is the extra cement gap, because that's going to be your fit along the axial walls. And we can just see what that change looks like applied here. It's not going to be much change, so you can go ahead and just change it by like 10 or so microns at a time, seeing which is going to be the best setting for you at that time. So now applied to the first unit, it's now going to apply that setting to the second unit. So I'm going to make the same change, just bumping it up 10 microns. Then we'll move on to the next stage. So with this stage, we now go into the same option. Again, it automatically connects to the margin line. I always undo that. So I start with 3 blank teeth. And again, I can change my smile library if I wanted to, but I'm just going to use the one that we currently started with. And first off, I'm going to start with group transformation. Group transformation basically allows us to take the teeth as they are setting in as a group. So maybe this one's not the greatest one because the idealization of the crown's kind of messed up a little bit. So I'm going to choose just this one here real quick. If I choose a new library, it basically brings in the teeth anew based upon the library that we chose. Allows us to go ahead and select what we want. So I'm going to go ahead and put them in. Left that on from the last one and put them into position. And you use my big changes first, which is going to be the multiple teeth change. It allows us to go ahead and keep the 3 units in their current setup and make the changes necessary or adjustments necessary. So I'm going to go ahead and bring this out. Maybe I actually bring this over, make these changes. Okay. I feel like this premolar might be a little bit big, so I'm going to change this premolar real quick. If I hold the shift key, not the shift key. If I hold the control key, it allows me to shrink the size uniformly. So rather than just dragging in that side, which makes it skinnier, I can actually bring the control key in. It allows me to kind of size up and size down that individual piece there. And then I'm going to go ahead and rotate this so it follows a little bit more in line with the arc that we have going on here. Same thing with this one. I'm going to bring it a little bit more mesially like that, and then bring distal out a little bit. Okay. And then we can go ahead and formulate this one to be a little bit longer as well. All right. Once I've made those changes, it actually adapts those changes to the whole 3 units as a whole. So if I go back to my multiple teeth change, now they're going to keep those changes that we just encapsulated there. So I'm going to go ahead and just make the necessary changes that we see here. So now moving on to single teeth tools, because I think they look pretty good as they're sitting here. I might need to change this one just ever so slightly, rotate it, drag it out, make it a little bit wider. So it kind of encapsulates there. See how this lateral looks a little bit more skinnier. So I might drag this one in skinnier and taller, make it lean out a little bit more. Drag that one down. And it doesn't matter how far we drag it down, it can come through the model okay, because we do have that option to connect to the margin line afterwards. So I'm always just kind of aware of that as a function that we have available to us. So the biggest difference between single tooth crown design and bridge design is that we just kind of have to pay attention that we're not designing one tooth at a time, we're designing the 3 teeth at the same time. And typically what that envelops is just making sure that the necessary contacts between those teeth aren't going to be overdeveloped. And so we don't want them to be unnaturally looking over here versus the contacts that we're going to be paying attention to with our models are going to be relative to our neighboring teeth. So we just kind of make that change as necessary. So I'm going to go actually develop this a little bit more with my medium change tool or intermediate change tool, which is going to be that morphing tool. And this allows me to suck in or suck out certain areas of our design to kind of encapsulate those median changes. Maybe suck this out, maybe tuck this one back in. Maybe he's too far. No, he's actually looking pretty good there. So that looks fine. Again, I could spend more time on the change, but I really want to go over the details and the differences that we have within these settings. And the biggest one was during this stage, we do have an additional option, which is to move the teeth as a group function. Okay. So much the same with our crown designs. We're going to go through the same processes that we went through just previously. I'm going to say that I have them correctly situated where I want them to be. I'm going to make my necessary adjustments over here. Okay. I build out this area. I might build out this area on the cuspid. Okay. Again, making sure that we're not building up too much in this area. Okay. And kind of removing all sorts of food traps that I just created in my design over here. And then I'm going to go ahead and attach them to the margin line. Now with the 2 crowns over here, we can see that those will attach nicely to a margin line, but we notice with that pontic, there is no connection to the margin line. That's because we have a different setting for the pontic, okay? So first what we're going to do is we're just going to go ahead and apply these settings. I'm going to apply to all. So it applies to both my lateral and my bicuspid, and then make any necessary changes as needed. So I might bulk this out a little bit more. Okay, looks good. We can see that the pontic still is kind of sitting a little bit flat. So I'm going to go over to first my smart tools. Actually, first I'm going to use the smooth tool to kind of smooth up this ridge that we see along the side here. So it looks a little bit more natural as it curves into that ridge. So with the absence of an option to connect it to a margin line, because it has no margin line, the pontic needs to be cut to the individual model that we have scanned in. Now to do that, we have to use our smart tools, and we have to be selected on the unit. The way that we select between the individual units is by clicking on it once, and you'll see the change appear over here in our map. This map indicates with the green or with the gray arrow what unit we're currently selected on. So I can select on the pontic, or I can physically select it up over here as well to ensure that I'm selected on the pontic. Once we select on the pontic and we go to our smart tools, there's an option that's only relative to pontics, which is the desired distance to the gingiva. Okay, so this is going to take the unit off the gingiva this amount. So I'm going to go ahead and apply that change, and it removes the unit from touching the model as best as it can. Now, what happens when it does that is it doesn't take into consideration any design features of that pontic. It just removes it to the existing relation to the model. So I then go and I take my smooth tool. I'm going to go ahead and smooth up that finite edge, because sometimes it does create this knife edge, which isn't always desirable and doesn't always feel good. So I always smooth that up just relatively quick. And then I take a look at the design and I make sure that there's no ridge lap. So I don't like any sort of ridge lap on my units. So I'm going to go ahead and smooth up this ridge on the back, on the lingual side, to ensure that there's not going to be any sort of ridge lap on the pontic area. Okay. So once we have that design solidified, we can then go ahead and take a look at all our units together and see how they look and make any adjustments as needed. So if I turn on my minimum thickness, I can see that I'm very thin here. So I'm going to go back to a bigger change tool, and I'm just going to use the morphing tool to go ahead and drag this out. Okay, making sure that I'm clicking and dragging up to add material to that area. And then I can go ahead and use my smooth tool as needed. If I wanted to go in and design any sort of occlusal anatomy, I can with the subtraction tool. So I can go in and carve, like I said, with a nice strong line. Just go ahead and design my anatomy. Okay. And then once I have that design, I'm going to go in about 2 clicks above, not as intense. I always make that mistake. And just undoing is just a Control Z, which allows us to go ahead and undo that. And then just kind of subtracting that design. Maybe a little bit more intense. Okay. So once we have our design looking good, we know that it meets the minimum thickness because I don't see anything coming through. Now what we're going to do is we're going to take a look at how these units are, again, touching the interproximals. So with the pontic, the interproximal is just going to be our neighboring units. So as long as we're coming into contact and not coming through the tooth on either side, you should be fine. So this looks fine. As long as I don't see any daylight coming through, I know that I have a nice solidified contact between those two areas. But the teeth that are touching neighboring teeth, like our lateral here, we're going to go ahead and turn on this feature again, which is under our wax knife. We're going to go to the subtraction tool. We're going to go to neighboring teeth undercuts, and we're going to turn on that negative 0.05. Oh, I hit enter again. Sorry, didn't mean to. Okay, so we're going to go ahead and add where we want to add. If we wanted to make it a little bit more brazen or emboldened, we can go ahead and add. But it's only going to add so much to that contact, okay? And then I'm going to subtract again, just to kind of solidify it a little bit more. And wherever I turn that off, so if I turn that feature off, just take a look and you can kind of see a nice contact area in here. I'm just going to go ahead and smooth up around those edges so it's not as sharp around the edge. I'm going to do the same thing with this tooth. So I'm going to click on it once, go over to my minus, and turn on that negative teeth undercuts tool to develop a nice contact area. And wherever it's a little bit too heavy, I'm going to go ahead and just remove this feature. So here I have a nice contact. I can turn on my contacts if I want to see it. And now I'm going to go ahead and turn off the neighboring teeth contacts so I can smooth just along that red line to ensure that we're not going to have a sharp contact area. Now, we do have a little bit of an area that's contacting here and here, as well as here with our opposing. So we can go to our smart tools. Now we can use that desired distance to antagonist. We can hit the play button. And that play button just applies to the single unit that we have. But if we have multiple units, we can hit the double play button, and that applies to all units. So here we have a kind of battle between minimum thickness and distance to occlusion. So I always allow the distance to occlusion to go first, and then I hit minimum thickness to apply that as a secondary option. So we know that we're always going to be at least minimally thick. I know that I may have a fight between finishing this unit versus going too thin with the material structure, but I always allow the material structure to meet the minimum thickness requirements. So that way we're never going to be below the standard that we're looking for that minimum thickness to meet the strength that we're looking for. And under here, again, I just don't like the unit touching the gingiva, so I'm just going to subtract a little bit over here, and we're good to go. Okay, so here we have our nice design. Made sure that our Pontic does not have a ridge lap. All right, we can take a look again, looking at our units. If we wanted to, we can make final changes as needed. But I don't know that my posing wheel really, it'll allow for me to go ahead and scope this up a little bit here. Okay. And if you're a better designer than me, it'd look a lot better than what we have on screen. But at least we know the functionality of what this is supposed to look like. And we can see that we're out of occlusion a certain amount. We do have an issue with our occlusion over here relative to our minimum thickness, but we're always going to allow that minimum thickness to take precedence. You never want to mill something out without the minimum thickness being met, because then you run the risk of running into milling out holes or issues with the strength relative to that certain area. So we're going to go ahead and say that this is good to go. We're going to go ahead and move on to the next stage, because right now we've treated these units as 3 individual units. We're going to go ahead and move on to the next stage, which combines them into one monolithic design. And this allows us to go ahead and see if there's any issue with those pieces. Okay, so we're going to go ahead and hit next. And now, rather than being 3 individual units, you can see that the gray is highlighting that whole bridge. So it's one monolithic structure. I can make any sort of last minute changes at this moment, but simply what I'm going to say is if we looked at, we saw that our unit was good in design and functionality, I like to go along the interproximals just briefly, just to kind of smooth it up, and you can kind of see it emboldens that connection between those 2 units. So I just use the smooth tool ever so slightly, and this allows us to go ahead and see what that final unit will look like as a bridge. And I can turn off my model here. This allows me to get the underside. Finally, what we need to do is, with all bridges, we need to check that the connection between units is going to be satisfactory as far as minimum thickness goes. So I'm going to use the 2D cross-section tool, and this allows us to go ahead and measure the area of that to ensure that we have a nice thickness. With full contour, we're looking at about 12 millimeters squared for our anteriors, or we're looking at about 15 millimeters squared for our posteriors. So I'm going to go ahead and measure this one over here as well, and we can see whether or not we're meeting that minimum thickness. So yep, we have 12 millimeters between our interproximals on our lateral and cuspid, and we also have 12 millimeters squared on our cuspid and bicuspid as well. So functionality, this bridge is going to be good. We have nice solidified connectors interproximally between these units, and it fits snugly between the units that we have neighboring it as well, Jason. And we know that we have that one issue on the occlusion, but otherwise everything looks good. So we have a nice, well-designed bridge, and that's basically all we have to do. So after the bridge is done, we go ahead and we hit next. It's going to again analyze to make sure there's no issues with the unit itself. If there's any issues, it will present itself at this time, and you have to make those adjustments in previous stages. Once we're all done, we're going to go ahead and hit close, and we're good to go. So with that said, thank you very much for taking the time to listen to my presentation today. If you guys have any questions, I'm more than open to do that. Fran, if you could, please just send out the last poll so that we can see how you guys feel with the confidence of what we're looking at with our designs and the techniques that I've shown you today, how confident you guys feel with designing single units or 3-unit bridges going forward. If you guys have any questions, please, let's go ahead and take those.
We do have a question. Alexandra wants to know if you can please show again how you verified the bridge connections have the appropriate thickness.
Yeah, of course. So going back to 3Shape. Well, let's see here. So if we go into, if we just look at the design, so it's the same thing as the 2D cross-section does. So if I take a look at the design here, I'm just opening up the design using Shift F4 when in the Dental Manager. So I can see my STL file that I have here. If I bring that into the 3D viewer, that's kind of like a similar tool that we have available to us. There's this option here that's called the 2D cross-section tool. And this is an option that is available to us during design as well. And this allows us to go ahead and draw a line from whatever view we're currently looking at And this allows us to dissect that model and show exactly what that model looks like in a 2D cross section. Now, a thing that I don't have in this stage that I do have in the design stage is there's an option to check the area. So I guess I should go back to the design real quick, see if I can open it. We're going to go into redesign here. So that's a great question. Yeah. So checking the connectors to make sure that they're thick enough is very vital to ensuring that you have a successful bridge. So I'm just pushing all the way through the major steps, and it's going to go ahead and apply all the changes that I've done so far. The more clicks, the longer it's going to take to go through each of these individual stages. So typically being a little bit conservative with your clicks helps to up the processing time or reduce the processing time of these and allow you to kind of reach the final stage a little bit quicker. So since I had to do a lot of changes because my design was not so good, it's going to take into account how long it took me to make those changes and apply those individual clicks or those individual changes as needed. But once we go into the final stage, like I said, with the 2D cross-section tool, we can draw down the interproximal and just kind of highlight just that area that we're looking for. So you can see this is our tooth over here. This is our model in the 2D cross-section, but this is our tooth. And this, specifically, that's the area that we've cross-sected or dissected there. And then there's a measure area portion. The measure area portion allows us to go ahead and view that specific cross-section and kind of measure the distance or measure the overall squared area of that cross-sected area. Okay. Again, if I wanted to check this one, I'm going to go ahead and remove my cross-section that I did along the lateral and the cuspid. And I'm going to go ahead and dissect this area along this cross-section here. Again, click on this little square tool, which shows the area. And we can see that one is a little underdeveloped. So maybe I need to build up that one a little bit more. So I can either click and drag this area out a little bit, which allows me to kind of increase that area, or I can use the adding tool and just kind of add to that specific area as well. But those are ways that we measure those contact areas, and achieving that 12 millimeters squared on the anteriors is important to the structural rigidity of those bridges. And then again, we like to look for at least 15 millimeters squared when doing full contour zirconia on posteriors. So anything from premolars backwards, we look for 15 millimeters squared. Okay. Any other questions?
Right now, it doesn't seem that we have any, but I'll be monitoring them. But I just wanted to let you know that 100% of our attendees feel very confident moving forward in design of a 3-unit and a single. So thank you so much, Matt.
Perfect.
100% also of our attendees are 3Shape users and have been using 3Shape for at least 6 months. So
Perfect.
this was really great. I really appreciate you taking the time and being able, to teach our attendees how to do this. It's fantastic.